In this video, we're going to walk through homework 3, and I recommend that you have your questions displayed on your device and your notebook by hand. So let's do it together. Number 1, write the equation of the circle given below in standard form. Identify the center and radius of the circle and graph it. Label 4 points on the graph with coordinates. So let's do the first part. First part, let me write down the equation. X squared plus y squared minus 6x plus 4y and minus 4 equals 0. Let me move this a little bit to this spot because I do kind of want to write down the equation of the circle so that it's easy for you to see what we are trying to do. Let's write down the equation of the circle. So the equation of the circle is this, x minus, I forgot the notation for the center. It could be h and k. Correct me if I'm wrong. So x minus h squared plus y minus k squared equals r squared. So in this case, h comma k is the center, and then r is the radius. So the center, let's write it out. Center is h comma k. So essentially, after you complete the square, it's the opposite number that you see inside. And then radius is r. All right, so that is your goal. And now let's complete the square. Where's the color? Okay. I'm going to look at my work, just make sure that I did everything correctly. Okay, so completing the square requires us to first move some of the terms. So if you take a look at what we have, I'm going to put all the x's together and all the y's together. X squared minus 6x, right? So those two terms have x. And then I have y squared plus 4y, right? And then I'm going to move the negative 4 to the other side. So that will become positive 4. So this is what you want to do. You want to put the constant term in the equation to the other side. And then you want to group the x terms together, group the y terms together, and then complete the square. So for completing the square, I'm going to do 2 boxes using the box method. And of course, you could use formula method. The formulas are on one of the previous handouts on completing the square. So make sure you check it out if you want to use formulas. So first term is x squared. It goes to the top left, right? And it tells you that the side length is x and x. And then the second term is negative 6x. We're going to divide it into 2 terms that equals. So it will be negative 3x right here, and then negative 3x right here. This tells us that the side length of this rectangle, one of them is negative 3. Same thing over here, negative 3. And then we multiply negative 3 and negative 3 to get the area of the missing square at the bottom right. Negative 3 times negative 3 is positive 9. So we're adding 9 to x squared minus 6x, and that will complete the square. And this will give you x minus 3 squared. And now let's do the same thing for the y's. I'm going to do a square and then divide it into 4 parts. The top left will be y squared, which means the side length are y and y. And then the second term for y, we're going to divide it by 2. So you have 2y and 2y. That means the side length of the rectangle is positive 2. And then I multiply 2 and 2 together to calculate the missing square on the bottom right. It's positive 4. So that tells me that I need to add 4 to complete the square. And when we complete the square, this y becomes y plus 2 squared. And then in between, you should see that there's a plus sign. So we're going to put the plus sign there. Equals, on the right-hand side, we're going to do the same thing because it is an equation. So what you do to the left-hand side, you're going to do the same thing to the right-hand side. So I need to add 9 and add 4. And then we're going to calculate what that is, right? So 4 plus 9 is 13. 13 plus 4 is 17. And now we completed the square. We also had this form that satisfied the circle form on the top. So that means the center is, you just do the opposite numbers that you see inside the squares. It will be positive 3 and negative 2. And then radius is square root of 17. Okay, and then the next part is graphing this circle. To graph this circle, what I recommend is that you start with the center and then you find 4 points that are on the circle based on the radius. So if you calculate square root of 17, you should be able to get a number. Square root of 17, I believe it's let's actually calculate what that is. Right, I'm gonna calculate what that is. Calculate square root of 17. Oh my god, too many commercials. All right. Square root, oh jeez. Square root of 17. Oh, finally. So it's about 4.1. That's what the square root of 17 is. So it's approximately 4.1 or approximately 4. So I'm going to do a coordinate plan. And then mark the center. The center is 3, negative 2. So 1, 2, 3. 1, 2. So it's right here. That's the center. And then using approximately 4 to find 4 points, right? So I'm gonna do 1, 2, 3, 4, and then slightly above because it's about 4.1. So this will be going up. I find 1 point, right? And then I do go to the left, 1, 2, 3, 4, and then slightly over. So that will be my second point. And then going down, 1, 2, 3, 4, and then slightly over, my third point. And then go to the right, 1, 2, 3, 4, and then slightly to the right, and my fourth point. And now you could connect them. And of course, it's not going to be super perfect, but it's fine. We got the job done. So that would be the sketch of this one. All right. And for part B, let's add a page. Let's write down the equation. Part B is x squared plus y squared plus ax minus 2y minus 8 equals 0. So same thing, right? We regroup the terms and move the constant term to the right-hand side. X squared plus ax will go together. And then plus y squared minus 2y, they will go together. Equals negative 8 moved to the right becomes positive 8. And then we complete the square. So this time I'm just, let me not skip the steps. So we have the square, and I'm going to divide it into 4 parts. Top left, x squared. Second term is ax, so we divide it by 2. You have 4x and 4x. So that means the side length is x plus 4. And the number that we're going to add is 4 times 4, and that's positive 16. So we add 16 to x, and we're going to do the same thing on the other side. And then we work on the y's. So square. Yeah, it doesn't look like a square. And then dividing into 4 terms. We have y squared, negative y. So that means the side length is y minus 1. And that means the number that we're going to add is positive 1. So we're going to add the 1 on both sides. And then we will write the completed square on the left-hand side. The first square is x plus 4 squared plus the second square is y minus 1 squared. And the number on the right-hand side is a plus 16 plus 1. That is 24 plus 1, which is 25. Finally, a perfect square. So that means it'll be easier for us to sketch now. And we're going to write down the center. Center will be the opposite numbers in the square. So that's negative 4 and positive 1. And the radius is square root of 25, which is 5. And then to sketch it, we will do a coordinate plan. Actually, I'm using this grid, right? Why didn't I use the grid? How silly of me. So I'm going to use the grid. Okay, so on this grid, I'm going to first mark negative 4, comma 1. So 1, 2, 3, 4, comma 1, which is right here. And then using the radius 5 to find 4 points. So I go up 5 times. 1, 2, 3, 4, 5. First point. Go to the left. 1, 2, 3, 4, 5. Second point. 1, 2, 3, 4, 5. Third point. 1, 2, 3, 4, 5. Fourth point. And now I have all the points. I'm going to connect them as a smooth curve. And hopefully it looks like a circle. All right, it's a circle. So that's part B. Next, part C. Part C is x squared plus y squared plus 10x plus 6y plus 18 equals 0. So we're going to regroup the terms. X squared plus 10x plus y squared plus 6y. And then equals, the constant term moved to the right will be negative 18. And then we're going to complete the square. So let's do 2 squares. The first square will start with x squared, and we're going to divide up 10x by 2. So we have 5x and 5x. And that tells us the side length of the square is x plus 5 and x plus 5. And the number that we're adding on both sides will be 5 times 5. And that's positive 25. So plus positive 25 on both sides. Next, we're going to do the y. Do a square. And then we're going to write down y squared first. And then we have 6y divided by 2. So that would be 3y and 3y. And it tells us that the side length of this square is y plus 3 and y plus 3. The number that we're adding on both sides of the equation will be 3 times 3, which is positive 9. So you add positive 9 on the left-hand side, add positive 9 on the right-hand side of the equation. Let's write down the completed squares on the left-hand side. The first square is x plus 5 squared plus the second square is y plus 3 squared equals, so negative 18 plus 25, that's positive 7. 7 plus 9, that's 16. This is nice. 16 is a perfect square. And I still hate part A. Part C is much better. Part B too. The radius is a perfect square. Radius squared is a perfect square. Okay, let's identify the center and the radius. Center will be the opposite numbers that you see inside. So that'll be negative 5, negative 3. And then radius will be the square root of 16. So that's 4. And let's make a sketch. I'm going to use the grid. Be smart about it. And let's see. So the center is negative 5, negative 3. 1, 2, 3, 4, 5, 1, 2, 3, so negative 5, negative 3. I guess I should expand it. Yeah, I might run out of space. That's right. So I will. Good thing I'm on iPad, so I could actually do this. Let's erase this part. I'm gonna adjust my coordinates a little bit. All right. So negative 5, negative 3 is the center, and then radius is 4. So I'm gonna go up 4 times. 1, 2, 3, 4. Go to the left. 1, 2, 3, 4. Go down. 1, 2, 3, 4. Go to the right. 1, 2, 3, 4. And connect them with a smooth curve. There you go. Okay, so that is part 1. Question 1. And I think, yeah, I have the solutions. I just didn't have the graph. So in this video, you have the graph as well. Now, let's move on to number 2. Number 2 is about solving system of equations that are not linear. So let's start with the first system. First system, 3x plus y equals 4. And then you have x squared minus 3y equals negative 32. Okay, so by observing this system, I noticed that in the second equation, there is x squared. And then for y, I can do the substitution to get rid of by using the first equation, which will give me a quadratic equation in x. So that would be my plan. I basically want to keep x but eliminate y. It's because x has a higher degree, so it's harder to get rid of. That's basically my logic. I'm going to label my equation first. It's just for teaching purpose. I have equation A and equation B, right? So the first step is, let me change the color. First step is I'm going to solve equation A for y. This is because I want to get expression of y so that I can plug it into equation B and eliminate the y in equation B. Copy equation A, 3x plus y equals 4. We're isolating y. So this is what we're trying to get rid of. And that means I need to do inverse operations. The inverse operation will be subtract 3x from both sides. And this will give me y equals 4 subtract 3x. And I can call this equation C. The next step is the substitution. I'm going to substitute this equation C into equation B. So equation B says x squared minus 3y equals negative 32. For y, I'm going to replace that with the expression of y in equation C, which is 4 minus 3x. And I'm going to copy the rest of this equation. X squared minus 3 times y equals negative 32. All right, and then we're going to distribute right here. Let's use color. So I'm going to distribute this negative 3 into the parentheses. Let's write down the result. So I have x squared minus 12, right? And then plus 9x equals negative 32. And then I'm going to, since it's a quadratic equation, it's probably better if I move everything to the left-hand side. So plus 32 on both sides. Plus 32 on both sides. This will give me x squared plus 9x and then plus 20 equals 0. And the left-hand side can be factored. So if you think about it a little bit, you should be able to factor it, right? X times x gives you x squared. 4 and 5 gives you 20, and 4 plus 5 is also 9. So the two numbers should be positive 4 and positive 5 equals 0. And then by the zero product property, each of them could be 0, which means x could be negative 4, y could be negative 5. And don't forget about y, right? Because remember, y is also a variable in the system. So we're going to use equation C to solve for y. Equation C is 4 minus 3x. So y equals 4 minus 3 times negative 4. And that is 4 plus 12, which is 16. And for the second one I wrote a typo. This should be x equals negative 5. So that means y is 4 minus 3 times negative 5. And this will be 4 plus 15, and that's 19. Let's see if that's right. Okay, so we do get the right solution. Let's write down them in coordinate form. The first is negative 4, comma 16. And the second is negative 5, comma 19. And they are the two solutions that I provided right there. Okay, part B. We have x squared plus y squared equals 5. X minus y squared equals negative 3. Again, we have two equations, A and B, so I'm going to label them. Let's think about what would be the best method, right? So one thing I did notice that I see positive y squared and negative y squared, which means if I add these two equations, they got canceled out. So I think that's what I would do. Sometimes substitution, sometimes elimination. Like for this one, elimination will be a better choice. So I'm going to add these two equations right away. And then once you add these two equations, you should see that these two cancel out. So all we have is x squared plus x, right, equals 2. And now I'm going to move everything to the left-hand side. So subtract 2 from both sides. X squared plus x minus 2 equals 0. And this, let's try and factor in, equals 0. X times x gives you x squared. Since the middle term is positive, the product is negative, I want a larger number to be the positive. So positive 2, negative 1. And you could test it out. It is correct. And by the zero product property, x plus 2 could be 0, or x minus 1 could be 0. So x is negative 2, or x is positive 1. And then we're going to deal with the annoying part, which is y. You could use either equation A or equation B. I think equation A is probably a good choice because there are more positive signs, right? So I'm going to plug them into equation A. So x squared plus y squared equals 5. And that equals to 4 plus y squared equals 5. So that means y squared is 1. And y has to be plus minus 1. So this is the square root property. And on the other side, when x is 1, let's plug it as well. 1 squared plus y squared equals 5. 1 plus y squared equals 5. Y squared is 4. So y is plus minus square root of 4, which is 2. And that means we're going to have 4 points. Let's see if that's the case. Yeah, we do have 4 points. Let's write down all of them. So the first will be negative 2, positive y, negative 2, negative y, right? So those are the 2 points from the first x. The second x will give you 1, comma 2, and then 1, comma negative 2. Okay, so that's part B. Part C, 4x minus y equals 2. X squared plus 2y equals 5. Let's see what we can do to this system. I have a feeling that I might eliminate y, but you could also use substitution. Some of you might thinking about substitution, right? Actually, substitution might not be bad. So I will probably do substitution. So for equation A, I'm going to solve A for y. And then I will plug this into equation B, kind of similar to what we did in part A. 4x minus y is 2. And I'm trying to isolate this y. So the first thing to do is I'm going to subtract 4x from both sides. And this will give me negative y equals 2 minus 4x. And then I'm going to get rid of the negative sign, which is just dividing everything by negative 1, or reverse the sign. So you could just reverse the sign. Y equals negative 2 positive 4x. And now I have this equation C, which I can use to plug into equation B. X squared plus 2 times y, and y is equation C, negative 2 plus 4x equals 5. Let's simplify this equation by distributing 2. X squared minus 4 plus ax equals 5. And then I'm going to subtract 5 from both sides because it's a quadratic equation, and reorganize the terms a bit. X squared plus ax minus 9 equals 0. And I would say this is also factorable. X and x gives you x squared. And if I do positive 9, negative 1, I will get the correct one, right? 9 times negative 1 is negative 9. 9 plus negative 1 is positive 8. Zero product property. X plus 9 could be 0. X minus 1 could be 0. So x is negative 9 or x is positive 1. To find out y, I'm going to use equation C. So equation C says y equals negative 2 plus 4 times x, and that's negative 9. Let's calculate what that is. So it's going to be negative 2 minus 36, and that's negative 38. When x is 1, y equals negative 2 plus 4 times x, which is 1, and that's negative 2 plus 4, and that's positive 2. So the two solutions, before I write it down, let's just check, see if it's right. So negative 9, negative 38, yeah, that's right. Negative 9, negative 38. And then the second point is 1, 2. Okay, and that's part C. Part D. Part D, we have x squared minus y squared equals 3. 2x plus y squared equals 5. Okay, so this one looks like part B, right? I have the positive y squared, negative y squared again. So I'm going to add them. Let's add them. I will add these two equations. The y squared will cancel out, and I will obtain x squared plus 2x equals 8. I'm going to move the 8 to the left-hand side, so x squared plus 2x minus 8 equals 0. Let's try and factor the left-hand side. X times x gives you x squared. I'm going to do positive 4 and negative 2, because positive 4 times negative 2 is negative 8. Positive 4 plus negative 2 is positive 2. Zero product property, x plus 4 is 0, or x minus 2 is 0. So that tells us x is negative 4, or x is positive 2. And then to solve for y, you could use either the first equation or the second equation. I think the second equation is a little bit easier, just because the y squared has a positive sign. So let's use the second equation. Second equation says 2 times x, so 2 times negative 4 plus y squared equals 5. So that's negative 8 plus y squared equals 5. Plus a on both sides, y squared is 13, and y is plus minus square root of 13. And again, this is the square root property. For the second point, 2 times x, so 2 times 2 plus y squared equals 5. That's 4 plus y squared equals 5. Subtract 4 from both sides. Y squared is 1. Take a square root. Y is plus minus square root of 1, which is just 1. So again, we have 4 points. Let's see if it's right. Yeah, it is right. So let's write down all of the points. First 2 points is -4, positive square root of 13, -4, negative square root of 13. So that will be the first 2 pairs. The second 2 pairs will be 2, 1 and 2, -1. And that's part D. Finally, we're done with number 2. A very tedious problem set. Okay, number 3. Number 3 is solve 3 to the x equals 12 for x and round your answer to the nearest tenth. Let's write down the equation. 3 to the x equals 12. And as you can see, this is an exponential equation. For the exponential equation, the method that we talked about in class are just 2 of them. The first one is to rewrite both sides using the same base, right? For example, this one, on the left-hand side, exponent, the base is 3. So we will try to write 12 as a base of 3. And as you know, it's not possible using what we know by hand. So that leads us to the second method. The second method will require you to use the inverse operation of exponents, and which is probably going to use a calculator because you need to do log. So check out the exponents. It's on the left-hand side. We're going to do the inverse of exponents of 3. The inverse of exponents of 3 is log base of 3, right? And then if you remember, we will switch these 2 numbers in the equation. It's how we convert between an exponential equation and a logarithmic equation. So log base 3 of 12 is x. And you just use your calculator. On your calculator, if you have log base 3, then you could do that. But I know that most of your calculator doesn't have log base 3. That means you have to use the change of base formula. Right, so the change of base formula, let's say log base b of a, right, is equal to, you could change it to one of those 2 logs that you have on the calculator. The first one is the common log. Common log is just log, and the base is 10, and then you just do log base a over log base log of a and over log of b. So this is both base 10, or you could also do natural log. It's ln of a over ln of b. So whichever works for you. I will probably do ln, right? Because ln has 2 letters, log has 3 letters. Save some writing. So I'm going to do ln of 12 divided by ln of 3 equals x. And now you can go to your calculator and calculate the left-hand side, see what it is. If you did go, you should get approximately 3.3 for your x. So give it a try on your calculators. Make sure you know how to do this on your calculator. And that's part A. Oh, actually, that's the only part. Never mind. Yeah, that's the only part. And let's see if that's right. 2.3. 2.3. Oh, yeah, 2.3. Yeah, sorry. I had a different question. So it would be 2.3. Okay, we're going to move on to number 4. Evaluate the logarithm without using a calculator. Thank God you don't have to use a calculator this time. Part A. It's log base 2 of cube root of 2. So for this one, we will first rewrite the number inside this log function as a rational exponents. Rational exponents means that you don't have the radical sign anymore, but instead you will have an exponent whose exponent is a fraction. let's write down the log function. We don't change this, so it's log base 2. And then for the exponential part inside, the number inside is your base, which is 2. And then I'm going to add 1 right here. So the formula that I'm using is this one. If you have, let's say, nth root of a to the m, right? You have exponent inside, and you have the nth root outside where the index is the n. Then we can write it as a rational exponent where the base is a, and then you're going to use the exponent inside divided by the exponent, the index outside. So it's a to the m over n. This is the formula that I'm going to use. And now let's apply to this problem. Our base is 2, and then the exponent inside is 1. The index outside is 3. So I will rewrite cube root of 2 as 2 to the 1/3. And now we're going to cross out the inverse operations. So remember, log and exponents of the same base, they are inverse operations, meaning that log base 2 and exponents of 2, they're inverse operations. Inverse operations cancel each other out, so you can cross them out. And all we have left is 1/3. Let's do part B. Before we do that, let's check 1/3. Okay, part B is log base 3 of 1/9. And same thing, right? So we're going to keep the log function. I'm not going to change that. And then for 1/9, I'm going to rewrite it. So this time the rewrite function will be the negative exponents. So if you have 1 over a to the n, it's equal to a to the negative n. So if you remember, that's what we have. And then in this case, I can rewrite the number inside as 1/3 squared, right? And then I can apply the formula that I just wrote over there to convert this fraction inside into 3 to the negative 2. And now I can cross out the inverse operations, log base 3 and exponents of 3. They cancel out. We get negative 2. And let's see if it's right. Yeah, it's negative 2. Okay. Number 5. Let's add a page. For the given expressions, identify the quadrants in which the angle is located, find the reference angle, and then calculate the exact value. So the exact value, what that means is your answer must be non-terminating decimals. Not repeating or infinite decimals. Your answer has to be either a fraction, a terminating decimal, or a radical number. That's what the exact value means. So there's no rounding involved. Let's take a look at them. Part A is tangent of negative 135. And tangent of negative 135. So first of all, the value is negative. In order to identify which quadrant it is, it's probably better that you convert it to an angle that's between 0 degree and 360 degrees. So I'm going to do a coterminal angle of negative 135 by adding 360. And this will give you 225. So we could do a little sketch of the unit circle, or you could actually look at the unit circle as well if you want. Ooh, okay, not bad. I thought it's going to be bad. So starting with the initial side, right, let's use, I guess red is fine. So the initial side is always going to be this side. And then you're going to do counterclockwise because it's positive. You could still do negative. It's up to you which way you want to do. So I'm going to do, this will be 180 and this will be 225. So it's basically right here. It's the diagonal. If you do the negative 135, you will do clockwise. So it will be 90 degree first and then 45. So it's the same place. But that tells us that the angle is in the third quadrant. So you just use the Roman numeral number 3. And then second part is the reference angle, right? So the reference angle, you could look at the graph. I'm going to use green. It's the smallest acute angle between the horizontal axis and the terminal side. So it's basically this part. And this part is 45 degrees. So that's the reference angle. And by the way, your answer could also be in radians. I use numerical degrees because it's the easiest one to understand. And then what's next? Calculate the exact value. Okay, so next is calculate the exact value. So we will have, so you could just use unit circle, right? I would say just use unit circle. Tangent of, you could either do negative 135, or since I converted to 225, I'm going to do 225. 225. So you remember it's sine divided by cosine, right? So it's sine of 225 divided by cosine of 225. You could also use the reference angle. So let's go to the unit circle for 225. And then you could kind of see it's right here. 225, you have those two coordinates. They're exactly the same. They're both negative. So if you do a ratio, it's going to be positive 1. And then let's see if that's the correct answer. Yeah, third quadrant, 45 degrees and 1. All right. So that's part A. Part B, cosine of 240. Cosine of 240. So you could do a little bit of visualization again. It's going to be, I believe, very similar to the graph that we have above. It's basically 240, a little bit over 225. So I still start with this initial side, and I'm going to go more than, it's going to be more than the 225, right? 225, 240. So it's approximately right there. And that would be 240 degrees. It's still in the third quadrant. Let's write it out. Third quadrant. And the reference angle, let's take a look at the graph. It will be this part. So remember, it's the difference between the horizontal axis and the terminal side. And to calculate this part, you could use the angle measurement 240, subtract 180. Because the straight line is 180. So this will give you 60 degrees. Okay, 60 degrees. And then you could just use unit circle because this is also an angle that's on the unit circle. And it's cosine, so it should be pretty easy to identify. So let's go to your unit circle, 240. And we're looking at cosine, so you're looking at the x-coordinate. It's negative 1/2. All right, part C, sine of 330. Let's do a graph first. I think I'm going to put the graph here. Initial side right here. And then 330, so I'm going to go all the way to right here. It will be 270. And you still need to go a little bit further, all the way till maybe right here. And then you do a terminal side. And that's 330. Apparently this angle is in the fourth quadrant. And then the reference angle will be, let's use green, will be this part right here. So what you can do is 330 and 360, that's only 30-degree difference. And that's actually what the angle measure right here is, 30 degrees. And then for the actual exact value, you could use unit circle, sine of 330. And then you could look at the unit circle. It's right here, 330. We're looking at sine, so it's the y coordinate. It's also negative 1/2. Okay, part D, cosine of negative 120. So let's do a graph. And this time, I'm not going to change it to a positive angle. I'm just going to do clockwise to show you that you could still do it without changing it. Starting with the initial side, and then you're going to do clockwise. This will be 90 degrees, and you're going to do 30 more. So approximately right here. And then the reference angle will be this one right here. And the angle measurement, it will be 60 degrees. Let's write down the quadrant. Quadrant is quadrant 3. And the reference angle, as you can see, it's 120 over 90, so that's 30 degrees. So that's why that's 60 degrees. And in terms of the exact value, I'm going to use coterminal angles. So basically plus 360. This comes from the fact that the period of cosine is 360. If you do a full rotation, it's still the same angle. So that's 240 degrees. And then we're looking at the x coordinate. Didn't we do that earlier? Yeah, we did that in part B. So it's just negative 1/2. Okay, so I forgot to check the answers earlier, right? So let's double check the answer. So for part B, quadrant 3, 60 degrees, negative 1/2. For part C, quadrant 4, 30 degrees, and negative 1/2. Okay. For D, quadrant 3, 60 degrees, negative 1/2. Okay, very good. They're all good. And then we have part E. So let's add a page. Part E is cotangent, negative 5 pi over 4. So starting this one, we have some radians that are not very easy to identify. So I recommend that you convert it, if you want, to degrees. But you could still look at the unit circle. I'm going to keep it as radians, I guess. Negative 5 pi over 4. I'm going to convert it to a positive angle so that we could actually identify on the unit circle. Remember, the period is 2 pi. So I plus 2 pi. And then you're going to add these two fractions. So negative 5 pi over 4 plus, for this one is basically 2 pi over 1. And I want to convert to a fraction whose denominator is 4. So I multiply both the top and bottom by 4. The top becomes 8 pi because it's 2 pi times 4. Let me rewrite the pi. And the bottom is 1 times 4, which is 4. And now they have the same denominator, so I could add them. This will give you 3 pi over 4. And now you should be able to find this angle on the unit circle. 3 pi over 4, which is right here, right? It's in the second quadrant. It's 135 degrees. So I'm going to do third quadrant. Actually, let's visualize it first. So I have this unit circle. And then you have your initial side. So it's 135 degrees. It's the diagonal in the second quadrant. Second quadrant, and the reference angle is 45 degrees, or you could do pi over 4. Let me highlight that on the graph. It's just this part right here. That's 45 degrees, or equivalent to pi over 4. And then we have the exact value. For the exact value, which function are we looking at? We're looking at cotangent. Okay. So cotangent of this angle is the same as cotangent of 3 pi over 4. And cotangent, using the reciprocal identity, it's cosine divided by sine. So it's a cosine of this angle divided by sine of this angle. And then you're going to look at your unit circle, identify the two coordinates, right? So if you look at for 135 degrees or 3 pi over 4, the two coordinates, they are opposite numbers. So if I do a ratio, it's going to be -1. And let's see if it's right. Second quadrant, pi over 4, next. All right, that's right. Next, part F. Part F is cosecant of -4 pi over 3. So I'm going to do the same thing. I don't like how this fraction is negative. I'm going to convert it to a positive angle so that we can identify on the unit circle. Adding these two, that means I need to convert the second number into something over 3. -4 pi over 3 plus, so for the second part, denominator will become 3. I multiply by 3. I need to multiply 2 pi by 3 as well. That's 6 pi. And if I add them, I will get 2 pi over 3. So this is basically the coterminal angle. And you can look at your unit circle and see where it is. So 2 pi over 3 is also in the second quadrant. It's 120 degrees. Let's graph this. Okay. So it's in the second quadrant. And the reference angle is this one right here. Since it's 120, it's 60 degrees to 180. So that's the reference angle, or equivalent to pi over 3. I'm going to use the radian just because everything else is in radian in this part. All right, and finally the exact value. This one is the cosecant of -4 pi over 3. So that is cosecant of 2 pi over 3. Cosecant is the reciprocal of sine, so it's the 1 over sine of 2 pi over 3. And then use your unit circle. Sine of 2 pi over 3, it's radical 3 over 2. And we're taking a reciprocal of that, so it'll be 2 over radical 3. And as you can see, this is a number that has a radical part in the denominator. So we need to rationalize this by multiplying both the top and the bottom by radical 3. And this will give us 2 radical 3 over radical 9, which is 3. And let's check if you are right. Second quadrant, pi over 3, 2 radical 3 over 3. Yep. All right, next is part G. Part G is secant of 2 pi over 3. Okay, 2 pi over 3, we can handle that. It's on the unit circle, right? We just dealt with 2 pi over 3, so it's still second quadrant. And you can still do the visual if you want, or you could use the previous graph that we had for the 2 pi over 3. But for the sake of the video, I'm going to do the visual. So starting right here, that's the initial side. And the terminal side is at 120 degrees. And then based on the analysis before, the reference angle is 60, which is pi over 3. So reference is pi over 3. The exact value, we're looking at secant of 2 pi over 3. Secant, by the reciprocal identity, it's a 1 over cosine. So you look at your unit circle. 2 pi over 3, the x-coordinate is negative 1/2. We're taking the reciprocal of that, and that's negative 2. Let's check if it's right. So we have second quadrant, pi over 3, and negative 2. Yeah, that's right. Okay, so that's number 5. Finally, we're done with number 5. And then we have a few more questions. Number 6. For the given information, state the value of the given remaining trigonometric functions of theta. Okay. So part A. Part A, it tells you that sine of theta is 2 over 5. Cosine of theta is less than 0. So we know that the y-coordinate is, it basically tells us that the y-coordinate is positive, right? Because that's the sine. And then the x-coordinate is negative because the cosine is negative. And based on the analysis, it will have to be in the second quadrant, right? So you could kind of imagine where it is. It's in the second quadrant. So theta is in the second quadrant. And then once you have this, I will create a list of all the 5 trigonometric functions. Actually 6 trigonometric functions. There are a few ways that you could do it. You could use the Pythagorean identity, or you could use the Pythagorean theorem, which is actually what I recommend. What I mean by that is I usually just use the Pythagorean triangle instead of the Pythagorean identity, because it's just a little bit easier for me. But since I think we did it in class using the Pythagorean identity, I'm gonna stick to that so that you don't get confused. Okay, so Pythagorean identity says sine square, right, plus cosine square equals 1. Or the other way around, cosine square plus sine square equals 1. And then you plug in the numbers, so that will be 4 over 25 plus cosine square equals 1. And if I subtract 4 over 25 from both sides, first, before you subtract, you could rewrite 1 as 25 over 25, which will make the subtraction a little bit easier. And now we subtract 4 over 25 from both sides. Cosine square is 21 over 25. All right. And then because cosine is less than 0, so you will take a square root and put a negative sign outside. So it's negative square root of 21 over 5. All right, now let's list out all 6 trigonometric functions. I think I'm going to use a different color just to show this is the final results. So sine of theta, I'm going to write all 6 of them, is 2 over 5, right? And then cosine of theta, we just computed negative radical 21 over 5. And then tangent will be the ratio of these two. So I'm going to tell you a little trick, right? When you do the ratio of these two, notice that they have the same denominator. So it's basically dividing the numerators. So it would be negative 2 divided by radical 21. And then we're going to rationalize this by multiplying both the top and the bottom by radical 21. And this will give us negative 2 radical 21 over 21. Let me move this over here. Okay, so that will be the 3 main trigonometric functions. And then the next, we're going to look at the other 3. Let's use pink, I guess. First is the cosecant of theta. It's the reciprocal of sine, so that's why I put them together. And that will be 5 over 2. And then next will be secant of theta. It will be the reciprocal of cosine, so that's negative 5 over square root of 21. And we need to rationalize this, so I multiply both the top and the bottom by radical 21. And this will give you negative 5 radical 21 over 21. And finally, cotangent of theta is the reciprocal of tangent. So I'm going to use negative 2 over radical 21 as the number. So it's the number before we rationalized it. And then I flip it, so it will be negative radical 21 over 2. And now let's check, see if we are right. So cosine, okay, tangent, cosecant, secant, and finally cotangent. Okay, good. So as you can see, these kind of question, you just need to locate the terminal side of the angle, see which quadrant it is located, and then use the Pythagorean identity to figure out at least 2 of the trig functions, sine and cosine, and then the rest is just applying quotient identities, reciprocal identities. That's all you need. Okay, let's do part B. Part B says tangent is 2, and then sine is less than 0. So let's determine the sine, right? So sine is 0, which means your y has to be negative. And then what about your x? So for x, you're going to look at the tangent. Remember, tangent is sine divided by cosine. Since the quotient is positive and your sine is negative, which means cosine has to be negative as well. So it's negative, negative. That's how you get the positive. And our angle is in the third quadrant, right? In the third quadrant. In the third quadrant, both the coordinates are negative. And now let's look at how we're going to find the other values. So let's see if we know anything else about this angle. It tells us that the tangent is 2 and sine is negative. Okay, so I'm going to write down the definition. Tangent is sine divided by cosine, and that is 2. So from this relationship, we can note that sine of theta is 2 times cosine of theta. And then I'm going to apply the Pythagorean identity, right? So sine square plus cosine square equals 1. And notice that sine is 2 cosine, so that gives me 2 cosine squared, which is 4 cosine squared plus cosine squared equals 1. And then we combine the left-hand side. I get 5 cosine squared equals 1, which means cosine squared is 1 over 5. And because it's in the third quadrant, cosine should be negative. So it's going to be negative square root of 1 over 5. So that's 1 over radical 5. And we're going to rationalize this. So that's negative radical 5 over 5. And that's cosine. What about sine, right? Well, sine is, as I analyzed before, 2 times cosine. So it's negative 2 radical 5 over 5. And now it's time to write down all 6 trig functions. I'm going to start with sine, which I just calculated, negative 2 radical 5 over 5. Cosine is negative radical 5 over 5. And then we're going to do tangent. Tangent is sine divided by cosine. Again, they have the same denominator. They even have the same sign, so I can ignore all of them. I simply do 2 radical 5 divided by radical 5, and that is 2. But actually, we don't need to, right? Because tangent is given. It's just 2. I'm just verifying that tangent is 2 in this case. And then we are going to do the reciprocals. So cosecant is negative 5 over 2 radical 5. So I'm going to rationalize this. It's going to give you negative 5 radical 5 over 2 times 5, which is 10. And then 5 and 10 have a common factor of 5. So essentially, it's negative radical 5 over 2. Next one is secant. Secant will be the reciprocal of cosine. So that will be negative 5 over radical 5. If you simplify, it will be negative radical 5. And then cotangent is the reciprocal of tangent, so that will be 1/2. Let's verify, see if it's right. It says cosine is negative radical 5 over 5, sine is negative 2 radical 5 over 5, secant is negative radical 5, cosecant negative radical 5 over 2, and then cotangent 1/2. Okay, very good. It's correct. So that's part B. Part C. We have cosine is 2 over 3, and then tangent is less than 0. Okay, so cosine is 2 over 3, which means the x-coordinate is positive. It should be in the first or the fourth quadrant. And then tangent is negative. Again, tangent comes from sine divided by cosine. So if your cosine is positive, in order for the quotient to be negative, your sine has to be negative. So we got our sines of the angle. X is positive, y is negative. That means it's in the fourth quadrant. Now I'm going to set up the Pythagorean identity to find sine. So plug in sine squared plus cosine squared, that will be 4 over 9 equals 1. And I subtract 4 over 9 from both sides. I'm going to rewrite 1 as 9 over 9. If you subtract both sides by 4 over 9, we get 5 over 9. And then I take a square root. We know that sine is negative, so it's going to be negative radical 5 over radical 9, which is 3. And now we're ready to write the final values. I'm going to use the same color coding. My sine is negative radical 5 over 3. Cosine is 2 over 3. Tangent will be sine divided by cosine, so that would be negative. You could cross out the denominator, so it'll be negative radical 5 over 2. And then we're going to do the reciprocal. So first, cosecant will be negative 3 over radical 5. And we're going to rationalize this. And this will be negative 3 radical 5 over 5. And then secant is the reciprocal of 2 over 3, so that's 3 over 2. Cotangent is the reciprocal of tangent, so that will be negative 2 over radical 5. We rationalize this, and this will be negative 2 radical 5 over 5. And let's check if our answer is correct. Sine, negative radical 5 over 3. Tangent, negative radical 5 over 2. Cosecant, negative 3 radical 5 over 5. Secant, 3 over 2. Cotangent, negative 2 radical 5 over 5. Okay, good. All right, finally the last part, part D. Part D, cosine is 3 over 7, and then sine is less than 0. So let's determine the sign of the point. Your cosine is positive, x is positive. Your sine is negative, so your y is negative. This one is actually very easy to identify, right? So that means your x is positive, y is negative. It's in the fourth quadrant. And then we're going to use the Pythagorean identity to figure out sine. Plug it in. This will be 9 over 49 equals, so for 1, I'm going to rewrite it as 49 over 49. And then I subtract 9 over 49 on both sides. This will give me 40 over 49. And then I take a square root on both sides. I will get square root of 40 over 7. So square root of 40, let me do a quick analyze somewhere. Square root of 40, right? It's square root of 4, square root of 10. So that's 2 radical 10. It's 2 radical 10 over square root of 47. Square root of 49 is 7. And then it's negative. Don't forget about that. So we need to add a negative sign. I almost forgot. Okay. And now we are ready to write the final list. So we have sine negative 2 radical 10 over 7. Cosine is 3 over 7 given by the problem. And then tangent is the ratio. They have the same denominator, so I just simply divide them. So it'll be negative 2 radical 10 over 3. You just divide the numerators. And then do the reciprocals. First is cosecant. It'll be reciprocal of sine. Negative 7 over 2 radical 10. We're going to rationalize this. And that will be negative 7 radical 10 over 2 times 10, that's 20. Secant, it will be the reciprocal of cosine, so 7 over 3. Then cotangent will be the reciprocal of tangent, negative 3 over 2 radical 10. Rationalize this, radical 10, radical 10. This will be negative 3 radical 10 over 2 times 10, which is 20. Let's check, see if our answers are correct. Sine is negative 2 radical 10 over 7. Tangent negative 2 radical 10 over 3. Cosecant negative 7 radical 10 over 20. Secant 7 over 3. Cotangent negative 3 radical 10 over 20. Okay, perfect. And that is number 6. That is number 6. I know, a lot of work. Okay, number 7. Find the exact solutions to the trigonometric equations for x belong 0 to 2 pi. And there are 4 equations. Starting with the first one, I'm going to do 4 sine of x plus 2 equals 0. So basically your main job is isolate the trig function that you see in the equation. That's all you need to do. And then apply what you know about the angle to write the solutions. So for this one, we are going to do inverse operations. The inverse operation in this case will be subtract 2 first, right? So I'm not going to use color. I'm just going to do it right here just to save some time. So subtract 2 from both sides. I got 4 sine of x equals negative 2. And then I divide both sides by the coefficient of sine, which is 4. And I got that sine of x is negative 1/2. And then once you have this, what you can do is you can analyze where this angle is, right? So they tell you that x is between 0 and 2 pi, and sine of x is a negative, which means it has to be in the x is in the 3rd quadrant or the 4th quadrant. So that means we have 2 solutions. If I do a visual of what it looks like, I would do a unit circle, and then this time I will use colors. So your y is negative 1/2, which is basically like this. And there should be 2 angles. You could use your unit circle to identify that because negative 1/2 is a common value. Or you could use your calculator for that. So your x will be, I'm going to use the unit circle. The y coordinate is negative 1/2. And if you look at our unit circle, there are two such angles, right? One is 210, the other one is 330. Did the question mention about what kind of format the angle should be? I guess they want radians because the range that they gave you for x is in radians. So I'm going to use radians. It's 7 pi over 6, 11 pi over 6. And you don't need to do the plus minus k times 2 pi because our angle has to be between 0 and 2 pi. All right, part B. 6 cosine of x minus 3 equals 0. Same thing, we're going to isolate the trig function. So in this case, plus 3 on both sides. And that will give us 6 cosine of x equals 3. And then we divide both sides by coefficient of cosine, it's 6. And we obtain cosine is 1 over 2. Cosine is 1 over 2, meaning that your x is in 1 or 4th quadrant. And then we could do a visual right here. And I'm going to use red. So it will be approximately right here, right here. And then you have two angles. I'm going to use, again, unit circle to write my answer. X equals, I'm going to do the radians. So we're looking for 1 over 2 for the x coordinate. That would be pi over 3 and 5 pi over 3. Oh, I forgot to check my solution. Let's see. Number 1 is 7 pi over 6. Yeah, 11 pi over 6. Number 2, pi over 3, 5 pi over 3. Okay, perfect. All right, let's move on. Part C. 2 tangent of x minus 2 equals 0. So inverse operation, plus 2 on both sides. I have 2 tangent of x equals 2. And then I divide both sides by the coefficient of tangent, which is 2. Tangent of x is 1. Tangent of x is 1. We did something very similar. Your x, if you analyze, it will be in first or the third quadrant. And then if you do a visual of the graph, you're going to have a unit circle. And because tangent is 1, meaning that the x coordinate and the y coordinate must be the same number. So it's the diagonal of the first and the third quadrant. These are the two angles. And you're basically looking at points on the unit circle that have the same coordinates. And if you go back to unit circle, it will be 45 degrees and 225 degrees. In radians, pi over 4, 5 pi over 4. And let's see if it's right. Yep. All right, part D. 6 tangent of x equals negative 2 radical 3. Okay, so this one, there's just one inverse operation. We divide both sides by the coefficient of tangent, which is 6. And I got tangent of x is negative radical 3 over 3. And because tangent is negative, we conclude that x is in either the second quadrant or the fourth quadrant. So we could do a visual. And remember, tangent is sine divided by cosine. So the y coordinate and the x coordinate, first of all, they are opposites. They have negative signs. And second of the ratio is actually less than 1. And if I'm going to do a visual is basically saying that, let's think, sine divided by cosine. So cosine will be greater. And the graph should look somehow like this. Right? Cosine should be greater in terms of its absolute value. And we should have these two. And it has something to do with radical 3. So let's actually look at the unit circle. So what I see right here is that if I do sine divided by cosine, and I'm looking at 150 degrees, it's basically 1 divided by negative radical 3. That's negative radical 3 over 3. And that's actually what we want. So basically, we find out one of the angles. It's 5 pi over 6. And then you could just use the symmetry to find the other angle right here. And that's 11 pi over 6. And let's see if it's right. Yeah, it's right. And if you have trouble finding out this angle, you could also use your calculator using the tangent inverse of negative radical 3 over 3. And your calculator should give you one of the numbers. Your calculator should give you 11 pi over 6, but in the negative form. So you will have to convert it to the other two angles. And that's number 7. Let's move on to number 8. Given a triangle, we're going to draw a picture of the triangle and label it with the information provided. We're also going to run each answer to the nearest tenth, keeping 1 decimal place. And I also give you the formulas that you're going to use for this question. This question will require you to use the law of sines and the law of cosines. Depending on the problem, you might use one of them or both of them. So let's take a look at part A. Actually, before we do that, let's label our triangle. Oh yeah, we could label as we go. So part A says A is 12, B is 8, C is 5. Find angle C. So all you need to do is just do a very generic triangle like this. And then you could label A, B, C any way you want. I usually just do either clockwise or counterclockwise. And then the side of the triangle, it's the opposite of the angle, how you label it. So opposite of angle A, that's the side A. Opposite of angle B, that's side B. And then opposite of angle C, that's side C. So that would be how you label your triangle. And I'm going to put the numbers on the graph. In pink, A is 12, B is 8, and C is 5. And then we're looking for angle C, which is this one. And then you could check out the formulas. This one involves 3 sides and 1 angle. And apparently it will require you to use the law of cosines, because law of the cosines involves 3 sides and 1 angle. And the angle is between the 2 sides that you're interested in. So I'm going to write down one of the 3 equations from the law of cosines. So which one should you use, right? You might ask. It depends on the angle that you're looking at. So we're looking at angle C. That means I'm going to use the 3rd equation. Let's write it down. C squared equals A squared plus B squared minus 2AB times cosine of C. So this will be the one that you use. And now let's plug it in. C is 5. So 5 squared equals 12 squared plus A squared minus 2 times 12 times A times cosine of C. And you just need to solve this equation for cosine. With your calculator, you should get 25 equals 208 minus 192 cosine of C. So this part, you just use your calculator, calculate what's 12 squared plus A squared, what's 2 times 12 times 8, and what's 5 squared. And then you do inverse operation to isolate cosine of C. If you do inverse operation to isolate cosine of C, we will get cosine of C is 183 over 192. And then use your calculator to do the inverse of cosine. So your angle C will be the inverse of cosine of this fraction. And then for your final answer, let's see. This question did not say what kind of angle format it requires. It could be degrees or radians. I'm just going to use degrees. So it's approximately 17.6 degrees. Let's see. Yep, 17.6 degrees. So that would be part A, using the law of cosines. Part B, let's do the triangle first. And I'm going to label the same way, ABC, ABC. And then use pink to label the given information. Angle A is 50 degrees. Angle B, 75 degrees. And then A is 20. And it's looking for side B. So for this one, I think the best one to use will be the law of sines. Because this one, it involves two pairs of angle and its opposite sides. And if you look at the law of sines, it's ratios of sine of the angle and its opposite side. So you will use the law of sines. Particularly, it's connecting to angle A, angle B, side A, side B. So the equation I'm using is sine of A over A equals sine of B over B. You don't need sine of C or side C. And now let's plug in the numbers. Sine of A will be sine of 50 degrees divided by A, which is 20, equals sine of B, that's sine of 75 degrees, over B. And then you do cross multiplication, right? So sine of 50 times B equals 20 times sine of 75 degrees. Divide both sides by sine of 50. Your B is 20 times sine of 75 degrees divided by sine of 50 degrees. And then use your calculator. B is approximately 25.2. This is the side length, so it had nothing to do with radians or degrees, but you do want to make sure that your calculator is set to degrees because our angles are in degrees. And let's check, see if that's the correct answer. Yeah, 25.2. All right, moving on to part C. Do the triangle A, B, C, A, B, C. So this time B is 9, C is 6. Angle A is 67 degrees. Find side A. Find side A. So this time it's connecting, again, 3 sides and 1 angle. And that should give you an idea which law you're going to use, right? It's going to be the law of cosines. And let's pick the right one to use. And remember, the angle determines which one you're going to use. We're given angle A, so we're going to use the one that has angle A, which is the first equation. Write it down. A squared equals B squared plus C squared minus 2BC times cosine of A. And then plug in the numbers. We don't know what A is, so let's just keep it. A squared equals B is 9, so that's 9 squared, plus C is 6, 6 squared, minus 2 times 9 times 6 times cosine of 67 degrees. And then on the right hand side, you could enter the whole expression into your calculator. And if you do that, it will give you a number. Unfortunately, I don't have that number. My number is actually already simplified, so I'm just going to give you the final answer. So once you get the number on the right hand side, you're going to take a square root, and that will give you the value of A, which is approximately 8.6. And let's see if that's right. Yeah. So make sure you actually do the calculation and verify that you can get the answer. Okay, and then we have part D. Let's do another triangle right here. A, B, C, A, B, C. Label what's given. Angle C is 37 degrees. Angle B, 79 degrees. B is 13. Find side A. So for this one, it's kind of similar to part B if you don't see it. It's because we're looking at two sides and their opposite angles. And of course, one of the angle is not given, angle A, but they did give you angle B and angle C. You should know that in a triangle, the sum of all three interior angles, they add up to 180 degrees. So you are actually able to calculate angle A. And all you need to do is just subtract 180 by 37 and 79. So that should be the first thing you do, which is angle A. Calculate what that is. It's 180 degrees, subtract angle B, 79 degrees, subtract angle C, 37 degrees, and that will give you 64 degrees. Let's label that on the graph as well, 64 degrees. And now we have side A, side B, angle A, angle B, and that should remind you that we're going to use the law of sines. Very similar to part B. Let's write down sine of A divided by A, right, equals sine of B divided by B. And now let's plug in the numbers. So it's a sine of 64 degrees over A, we don't know what A is, equals sine of B, 79 degrees, divided by 13. And that means A is, if I do cross multiplication and isolate A, it's sine of 64 degrees times 13 divided by sine of 79 degrees. And if you use your calculator, it should give you approximately 11.9. And let's see if that's right. Yeah, 11.9. So for this one, there is a little challenge right here, right? If you're going to use one of the laws right away, you will find out that you can't. You have to use both of them in order to get what you want. But if you know the little trick right here that I showed you, you just need to use the law of sines in this case. Okay, last problem. Finally, last problem. Number 9. A 10-foot ladder is leaning up against a wall. Let's do a visual. You know it's going to be a right triangle, right? Because it's trig. Okay, and then we know that the ladder is 10 feet long and it has to be the hypotenuse. So you put 10 next to the hypotenuse. If the base of the ladder is situated 4 feet away from the base of the wall, okay, so you know that it's the base of the right triangle, that's 4 feet. What is the angle of elevation of the ladder? So it's talking about this angle right here. Let's label it as theta. So this is our angle that we're looking at. Draw a picture that depicts the situation, which we did, and label the relevant information. We also did that. We're going to round our answer to the nearest tenth of a degree. Perfect. So for this one, first you have the visual, and second, you're going to pick a trig function that involves the angle and the two sides. By looking at the triangle, we're looking at the adjacent and the hypotenuse. And based on SOHCAHTOA, we're going to use cosine. So that's what we're going to use. We're going to write down the ratio. Cosine is adjacent divided by hypotenuse, and that's 4 divided by 10. And you could simplify it or you could just leave it. I think you could just leave it because we're going to use calculator anyways. And then next is we're going to do the inverse of cosine. So cosine inverse, and then you switch the numbers, right? So 4 over 10 equals theta. And then use your calculator, calculate what cosine inverse of 4 over 10 is. And you should get your angle measure. Since this one requires you to use degrees, make sure that you set your mode to degrees. And it should be approximately 66.4 degrees. That's based on what I calculated. And let's see if that's right. So yeah, 66.4 degrees. And that's the end of homework 3. So I know that this is a very long homework and it has a lot of information that covered. Make sure that you review this as needed, especially for questions that you did not understand first. And thanks for watching this video.